Hello everyone and welcome to another video. So today we're doing something a little bit different. So we've got a science club put together with a couple of kids, and what we're trying to do is launch a high altitude weather balloon to carry this payload box up into the upper atmosphere. So the plan is to track the position of this payload box using a GPS and an Arduino hooked up to a radio transmitter, which is then going to broadcast its position via APRS. So this is going to broadcast on a very specific frequency, namely 144.39 megahertz. And what we would like to do is have an antenna to broadcast that information. So you can kind of see this Frankenstein antenna. You can kind of see the ground plane, which are these radial elements here, and then you have the main element down here, which is the active element. And really, this is actually kind of a homebrewed DIY antenna, and it's not particularly well tuned right now for this specific frequency that we want to transmit on. So what I want to talk about today is how can we use a very small, simple little device known as a NanoVNA to tune this antenna by basically changing the length of this main radial element until it's resonant at the frequency that this system is going to transmit on. So that's the game plan. Like I said, we're going to be using this small little device called the NanoVNA. These things are great. Basically, this is a miniature little vector network analyzer that will allow us to measure things like the SWR of an antenna. So these things are pretty nice because they're effectively an antenna analyzer packed into this small little cheap economical package. You know, a lot of antenna analyzers which help you do this function that we want to do on this antenna, you know, those things can range anywhere from, you know, $200 all the way up to, you know, like $1,000. Where for us, all we really want to do is get the length of this antenna correct so that it's resonant at the frequency that we desire. This little guy is nice because, yeah, you can get them for as low as, I think, $50. This is actually a NanoVNA version 2, and I paid around $80 for this unit. And what I'm going to talk about today is how we can use this to basically adjust the length of this main active element on our antenna to make sure that it is tuned for the right frequency. So, you know what? This might be a great time to actually, let's rewind time a little bit, and I'll show you what came in the box when I paid $80 for this NanoVNA, and then we'll see what comes with it. So again, this is the version 2 of it. So let me show you what came in the package. All right, so let's go ahead and get this guy out of the box. So the box is nothing special. Just says, yeah, NanoVNA. This is the version 2 in black. And again, I think it's probably fairly generic because I'm sure, as you may know, this NanoVNA is sort of an open source kind of project. So for the hardware, basically anyone can kind of really make this. So I don't think you have an official system or build. But yeah, it looks like this version that I got comes in this nice case. So let's open it up and see what we've got inside. Okay, so here it is. This looks very nice. Here's the actual unit. So again, this is the V2. The version 2 one, where I think these are kind of on the top of the unit. So at least this build has some of this nice plastic. This is always so much fun to take off. Okay, so there it is. It's got a nice metal housing. Yeah, it looks pretty good. You got the USB port there. You've got ports 1 and port 2. A couple other buttons. Okay, so yeah, this unit looks pretty reasonable. So that's the actual unit. Let's see what else comes in here. Got some information, I would assume. Maybe this is a getting started or a quick start guide. Oh yeah, hey, that's nice. So it actually kind of says which version of the firmware is on this, and it looks like it's got a little bit of a map of all of the different soft keys. Oh wow, that's great. It even has a location for, I guess, the GitLab repo where you can probably download and clone new releases of the firmware. And yeah, here's got a link to a user guide. So that's more than I was expecting. So we get some instructions for starting it up. Let's see what else we got in here. Okay, so we've got this handy little, I think, it's funny, I've heard this referred to as maybe like a plectrum. It's basically just a guitar pick that is going to help us push the touch screen on this this 320 by 240 pixel touchscreen, so that's nice. It looks like it's actually got a hook that I suppose you can probably stick it in. Yeah, there you go. It looks like you can kind of put it in one of these two sides, whichever one you want, I suppose. So let's see if that's, well, I'll tell you what, I'll do that later. So you get the little PIC plectrum thingy. You get a USB cable, pretty much standard USB, so one side going to your computer, and then yeah, this micro USB to kind of plug into the back of the NanoVNA. Let's see what else we got. Okay, so it looks like we have two. These, I believe, are 300 millimeter long SMA, yeah, male cable, so that'll help us make some connections, so that's nice. We've got two of those. And then, what have we got here? Okay. So I think these are some of the parts for the calibration set. So yeah, okay, we've got an SMA kind of coupler right here. So this is a female coupler there. And then we've got these three. So I believe it should be an open, a short, and then a kind of probably a 50 ohm load. So that's what these three parts are. So that'll help for calibrating the unit at various different frequencies. So that's nice. We got those. And then I guess we got a couple more kind of just random, yeah, kind of stuff for making cables, maybe a little some kind of gasket or O-rings. Okay, so there we go. That's what's included with the system. So not too shabby. Let's go ahead and get the battery charged up and turn it on. All right, so now that we've got the NanoVNA unboxed, what we're gonna do is let's just hook it up to channel 0. So as you can see, I've got the SMA cable coming from the antenna, and it is now going into channel 0 on the NanoVNA. And that's going to be important because that's the channel where we can do reflection and measure SWR for the antenna. So again, this antenna is nothing super spectacular. It's actually pretty darn simple. As we said, it basically has these 4 radial elements as sort of the ground plane, and then it has one single main vertical element. And again, the way I did this is, let me show you inside. I just 3D printed this little component, this holder, which is going to allow me to hold all of the ground plane wires and the main vertical element in this sort of 45-degree kind of star fashion. So if you're interested in that part, that 3D printed part, I'll go ahead and leave a link to that in the description of the video so you can download that and make your own. The idea with this antenna is you know, it's just I actually just got it off the internet, the design. The idea is that the main the main element is supposed to be around 19 and 7/16 inches long, and all of these radial elements are supposed to be 21.75 inches long. And all I did is I actually just constructed those elements excuse me, out of 14 gauge electrical wire. So that's all that these things are. So again, this is really simple. So what I did was I actually made the main element a little bit too long. It's always easier to cut it down shorter than it is to extend the length. So the idea is right now this main element is too long, and therefore this is probably not resonant at the 144.39 megahertz that we want. And now we've got it hooked up to the NanoVNA so we can actually measure it and see if that is true or not. And if it's not resonant at the right frequency, then what we can hopefully do is start chopping down and reducing the length of this main element to get it at the resonant at the proper frequencies. So I think we've got everything physically hooked up. Let's go ahead and turn on the NanoVNA and get started. All right, so now that we've got it all hooked up, let's go ahead and turn the NanoVNA on. So just flip the switch on the side to the up position and it turns on, but the screen is actually flipped in the upside down orientation from where I'm sitting. So to change that, that's really actually pretty simple. Just click in the middle and then click on display and then say flip display, and there we are. Now it's right side up. Now the other thing to notice is that there are like 4 traces right now. There is a yellow, green, a blue, and a purple trace set up. To make this easy, let's just look at how about only one. Let's just set up this blue channel to be the SWR. So we want to turn off all these other colors. So to do that, just click in the middle, then click on trace, and then you just need to start clicking on these to turn them off. So let's turn off the yellow one first. So you click on that, you see it goes away. Let's turn off the purple one. Let me click on that again. There, it goes away. And actually, before we turn off the green one, maybe what I will show you as well is if you are working with multiple channels, you can tell which channel you're currently manipulating by looking at this this box over here where it says here, you can see this says channel 1, and you see how there's a blue background behind it? That means that we currently have this blue trace selected for manipulation. The green one over here, if you notice, this green one is working on channel 0, and it's currently set up to be a Smith chart, which actually is kind of helpful, and I'm halfway tempted to leave this on, but I think we will turn it off eventually. But notice that the thing where it says channel 0 is not, it doesn't have a green background behind it, so we are not currently manipulating that channel. So if you want to select another channel for manipulation, all you need to do is click on it over here. And now after I clicked on it, notice that you get the green background. So now you can see that we are currently manipulating the green trace, which is currently set up to channel 0. So it's currently properly configured. So that's not what we're going to do. Let's go ahead and turn off the green. Okay, and then now we see that we only have the blue channel set up, but also it is set up to listen on channel 1, which is actually this terminal on this side over here, right? That's not quite right. We want to get SWR on channel 0, because channel 0 on the NanoVNA is what's set up to do the reflection measurements, right? Where we send out a sine wave and then we can measure whatever is reflected back. So we need to change this from saying channel 1 to saying channel 0. So to do that, that's actually pretty easy. Let's go ahead and click back. And then all you need to do is, since we currently have this blue trace selected, again, you can see that it's selected because it's got a blue background behind the word channel 1. We just need to change it. So I'm going to click on channel over here. So instead of 1, we need to go to channel 0, which, as you can clearly see labeled right here, that is set up to do reflection. So I'm going to click on reflect. There we are. Now it's set up, and you can see this now reads channel 0 for the blue trace, and this is pretty great. Now, the only thing that we need to worry about now is that this right now is set up to sweep over, I think for the NanoVNA version 2, this version I've got here is, I believe it does, I think it's 201 frequency sweep points from this starting frequency to the upper ending frequency. Now, it's set up over a pretty wide bandwidth right now, so we want to narrow it down to somewhere around this 144 megahertz that we're shooting for. So let's change the start and stop frequencies of our window of interest to the appropriate value. So to do that, go ahead and click on the middle to bring up the menu. Then let's go up to, I guess I have to hit back here to go back here. Aha, stimulus. So I'm going to click on stimulus, start. And let's start at, how about 120, and then I'm going to click M for megahertz. So now we're starting to sweep at 120 megahertz. Let's go all the way up to stop at, how about 160 megahertz. So somewhere in this range, it should capture that 144 megahertz that we're interested in, okay? All right, so actually, you can see that there's a minimum over here, so it's set up, it looks like this antenna. If I use the up and down buttons on the top of the NanoVNA to kind of get a rough idea, you can see here that we're getting, oh, actually, whoops, sorry. I just noticed we actually didn't set up the blue trace to be SWR. It is, right now, it's a log magnitude. I don't know if this is like a reflection coefficient, but long story short, we want to set this up to be SWR. So let's do that right now before we go any further. So to change what we are measuring on this blue trace, let's go ahead and, again, I'm going to go back, and then we are going to come here. I think it's display. No, was it? Oh no, sorry, I remember. It's actually, let me see, where is it? I want the format. Actually, here, Oh, it is here. Okay, so sorry. So let's go back to the top. So I do want display and then format. And then again, we have this, the blue trace currently selected. So I don't want log mag, I don't want phase, I don't want the delay, I don't want the Smith chart. I want SWR. So I'm gonna click on SWR. There we go. So now we see, here's our SWR chart. And again, we can see that down here, it actually looks like this antenna is currently set up pretty well for around 120 megahertz, because at that frequency, we've got an SWR of about, 1.3. So that's not too shabby. The other thing that maybe we should do right now is we should calibrate the NanoVNA for this particular frequency range that we have set up, so we can make sure that we're getting accurate measurements, okay? So to do that calibration, let's go ahead and unscrew the antenna. Okay, so I'll take off the antenna from the NanoVNA. Come on, come off. There we go. Okay, and now I'm going to click in the middle to bring up the menu, and let's go again, hit back to get yourself up to the top level, and then we're going to hit Cal for calibration. So here, now we go and click on Calibrate, and now for this situation, we need these test calibration connections that we saw came packaged with the NanoVNA. So let's do the open first. So the open was basically the infinite resistance. So I'm going to get that open one, that test component. I'm going to screw it on to channel 0, and then I'm going to click on the open and give it a second, and then you're going to see it kind of turn to that highlighted color. There it is. It's highlighted. So we got the data point for the open connection. The next one that you can see down this list is the short. So let me take off the open, and let me go ahead and grab the short, which was, I think, the 0 ohm kind of setup here. Okay, so I'll take the short circuit. I'm going to attach it, and then I'm going to click on short. Give it again a second to think about that. Take a data point there. Okay, great. And then lastly, I think what we need is the 50 ohm load, this guy. So let's go ahead and screw him on. Okay. And then click on the load. Give it a second to think again. All right, there it is. Now let's go ahead and take off the load. Okay, and now let's go ahead and click done. That's all we need to do. So let's click on done, and then we're gonna have to choose a channel or a slot to save this data to. So I'm just gonna click it to how about 0. Okay, so now we should have this calibrated for that frequency range that we just set up. So now let's go ahead and hook up the antenna again, and now we should hopefully be getting calibrated values. Okay, screw this thing on. Okay, there we are. Okay, so again, yeah, it looks like right now this thing is set up to actually be pretty well tuned for, 120 megahertz, something like that. Okay, so let's see, what is the SWR at the desired frequency that we are gunning for? So that is 144 megahertz-ish, right? So let's go up to 144 something, somewhere around here. Okay, so that's not super great. We got an SWR of about 3.35, okay? And in fact, why don't we zoom in a little bit? We'll go closer into that closer frequency realm to see what we can get. So let's go ahead and hit back, stimulus, start. How about now let's go at, I don't know, how about let's go 135 megahertz, and then we'll stop at, how about 150 megahertz? Okay, so just so we can zoom in a little bit and see a little bit. Okay, so now let's set this guy at 144.39-ish megahertz. That's pretty, well, here, let's go here. That's probably the closest point that we've got. Okay, so we've got this SWR of 3.07 or something like that, okay? So now what we might want to do is let's go ahead and start modifying the antenna. So let's start shaving it down and seeing if we can get this number down a little bit. So I'm going to cut a little bit off, see if that improves anything. Okay, so I just cut off, I don't know, a centimeter, 3.1, okay, maybe not. Let's cut a little more. Aha, there we go, okay, 2.9. Okay, so we're getting closer, we're making some improvements. Okay, let's cut a little bit more off. All right, 2.7, okay, that's pretty, it's getting there, a little bit more. Okay, so let's just go ahead and keep repeating this process of cutting down the antenna and seeing if we can get a little bit better SWR for this particular frequency. All right, so look at that. We've chopped it down. Here, I'll show you some of the parts. So here's some of the antenna pieces. So, I made, probably 10 or so cuts, but took about 1 centimeter off each time. And now look at this. So now we're much better. So now the SWR is about 1.6-ish. So this is like, half of what it used to be, which is great. So this looks a lot better for this particular frequency. And in fact, I think if we zoom out a little bit, hopefully we'll see that we got that minima about to the range that we're interested in. So I'm just going to open up the frequency band of our sweep a little bit more, back to that kind of 120 to 160 megahertz. And let's see. Yeah, look at that. That's great. So we moved the minima, about to this region. So we've tuned the antenna now a lot better for this particular frequency. All right, so there you have it. As you can see, that was actually a pretty simple, painless process to use this NanoVNA as effectively an antenna analyzer and allow us to trim and tune this antenna for our particular frequency of interest. Like I said, I think the great benefit of this is not only was it easy, but it's cheap, right? It's for $50 to $80 to be able to do this type of operation instead of having to buy, a $500 antenna analyzer is pretty darn great, and I'm very excited to play with this NanoVNA and see what else it can do in the context of RF engineering and frequency analysis. So with that being said, I think this is probably a great spot to leave it. I hope you enjoyed the video, and if so, I also hope you'll consider subscribing to the channel. Surprisingly, if you scroll a little ways down and click on that subscribe button, it really does help me continue making these videos. And remember, the new videos come out every Monday, so I hope we'll be able to catch you at one of these future discussions and we can all learn something new together. So until then, I think I'm going to sign off. Talk to you later. Bye.